Hi, this is a step-by-step guide on how to install Wireguard on Linux and Windows 10. I have two machines. The red window is a server that's running in the public cloud. It has a public IP address, and this will be the server that we connect to. The blue window is a client that's running inside my home network. Both of these are running Ubuntu 18.10, and there's nothing else installed. They're brand new machines. So we start by installing Wireguard on the server. The commands I will be putting in the text below, so you can look at it there. But we add the apt repository for Wireguard, and then we go ahead and do an apt update, and we install Wireguard. So we do that here. And of course, these instructions are on the Wireguard website, which is linked in the text below. So once that's installed, we do the same thing on the client. So let's just clear the screen on the server there. So now on the client, we do the same thing. We add the apt repository. So it's add-apt-repository bpa:/wireguard/wireguard. It takes a few seconds to add it. After that, apt update and apt install Wireguard. So now that Wireguard is installed on both machines, we have to set it up. Wireguard requires three things: a private key, a public key, and a conf file. So we'll start by setting up these three things on the server, and then we'll do it on the client. So the first thing we do is we have to go to the directory cd/etc/wireguard. So let's do that now. Then let's set a umask to 077 to make sure only root can read these files, and this is just for security. And now to set up the actual Wireguard private and public key, we can type one command to get them both done. So it's wg genkey pipe t private key pipe wg pubkey to public key. So if you type this in, it'll generate both the private and public key and save them in these two files, private key and public key. So now let's just print out the private key because we'll need that when we set up the conf file. I'll just print it out to the screen and then copy it into the clipboard. And now copy that to the clipboard, and that's it. Now let's create the conf file. So I'm going to use Nano, that's my preferred editor. So this is where you really start to see the simplicity of Wireguard. We add two sections. There's an interface section. The address over here is the server's IP address. That is, when the VPN tunnel is connected, the server will have the IP address of 192.168.9.1. We paste in the private key that I put into the clipboard, and we add the listen port. This is Wireguard's default port. It listens on UDP, so if you have any firewalls or something, you'll have to set that up, but currently I don't. Next section is the peer, that's the client section. We add the client's public key, which we don't have because we haven't set it up yet. And for the allowed IPs, we need to tell the Wireguard server what IP will be sending traffic. And I'm going to set the client to 9.2, and the 32 netmask means that only that IP will be allowed to send it. So that's the server config done. Now on the client, we have to do the same thing. We have to set up the private key, the public key, and the conf file. So let's go to etc/wireguard. Let's set our umask. And now let's set up the private and public keys with that same command: wg genkey pipe t private key pipe wg pubkey. And we send that to a file called publickkey. So now we have the private key and the public key. So let's just copy this public key and paste it into the server's config file so that the server is all done. So we don't have to think about that. So we take the public key out of the client, copy it, and open the file that we just created and paste it where it says public key under peer. Now, of course, I'm doing this on VM, so I can easily copy and paste. You could write it down, you could email it to yourself, however you want to change it, but you just have to get that information across. So on the server, we can set up, we can now get Wireguard up. So the command for that is wg-quick up wg0, where wg0 is the interface that we just created. And now it's up and running. It's listening on that port 51820. It's waiting for a client to connect to it. So let's go to our client and let's just create that. So first we print out the private key, and then we create a conf file on this one as well. So the interface on this machine, this is the client, and remember we set the IP address for the server as 9.1 and the peer as 9.2. So this one is 192.168.9.2, and the private key, which we just pasted into the clipboard, paste that in here. And since this is the client and there's nothing's going to be connecting to it, we don't need a listen port. For the peer, we need to connect to the server. We need the server's public key. So you can get that by typing WG on the server. You copy that, paste it in. We also need the endpoint IP address and port. So the public IP address for the server is 207.148.8.103, and we set the port to 51820. And finally, we tell it allowed IPs. That is the server's IP. So any traffic coming from the server has to come from this IP, and Wireguard will allow it to go through. Since we're behind NAT on the client, we also want to set a persistent keep alive to keep the tunnel alive. Every 25 seconds it'll ping. Otherwise, if you leave it for a long time, it'll die. So now it's set up. We can bring the interface up, WG quick up, WG 0, and believe it or not, it's actually, the tunnel is up right now. I'm connected to my public server. If I do a ping from the client to the server, it'll work, or vice versa. So let's just test that out. So the configuration is literally 6 or 7 lines of code, and it takes about 5 minutes to set this up. So the next thing we'll do is let's use iPerf and do some performance testing to see actually how fast Wireguard is. Right, now let's look at the performance testing using iPerf. So this is straightforward. If you've never used iPerf before, it's very easy to use. First thing to do is install it on both the server and the client. That's a simple apt install. I'm not going to go too far down the rabbit hole of iPerf testing. I'm just going to do some basic tests just to show the speed differences between OpenVPN or any other VPN service you may have used. So once I've installed it on both the server and the client, I'm going to start up the server on the server, if that makes sense. And then let's connect to it from the client. I'm going to set up about, let's say, 30 streams in parallel. And let's run it for 30 seconds, because that should be enough to show. Just a quick note, I am on a gigabit fiber connection at my home. That's gigabit upload and download. And of course, the server in the data center is on a really fast connection. So we should be able to get, well, 600 megabits per second easy. And I think this is actually CPU limited at this point, because I've seen much faster speeds when I'm using my desktop machine, which is obviously this VM client is nowhere near as fast as that. So clearly Wireguard, once it's set up, it is much faster than OpenVPN. I'm sure there are ways to tune OpenVPN, but I've honestly never seen OpenVPN on my hardware and my connection go over maybe 200 megabits per second. So this is like 3 times faster already. Quick note that right now the connection is set up in a point-to-point fashion. The client cannot talk to the internet through the server's internet connection, and the server cannot talk to anything behind the client, the LAN, anything like that. So the public IPs you can see on the left and the right are completely different. And so for the next thing we'll do is set it up so that the client can actually connect through the VPN, send all its traffic through the VPN to the internet and get traffic back. That's how most people want to use it, I assume. So that's pretty easy to do. If you've ever done IP masquerading on Linux, you'll know what to do, but let's just go over that in the next section. To enable it, we've got to make a few changes on the server. The first thing to do is edit the sysctl file and enable IPv4 forwarding. To do that, edit etc/sysctl.conf and search for net.ipv4.ip_forward and uncomment that line so it's set to 1, and save and exit this. Now to enable it, you could either reboot the machine, but in this case we just set it directly here on the command prompt. So the command to do that is sysctl-w and then net.ipv4.forward equals _forward equals 1. So if you do that, it sets it. So, and also when you reboot the machine, it will be set. So you don't have to think about this again. Now we need to know the interface name to put some IP table settings to get the interface name. On some machines it's ETH0, on some it's ENS. On this particular machine the public IP is on ENS3, that's the Ethernet adapter's identification. So once you know that, open up the w0.conf file that we've created before, and we have to add 2 lines to it to tell the computer what to do when the interface comes up and what to do when the interface goes down. You can copy and paste this information from the video description. Just make sure to use the correct interface name for your machine. It might be ETH0 or ENS1 or something else. So type all that in or copy and paste it, save and exit. And now we have to take the interface down and bring it back up again so that the changes are live. So the commands are simple, wg-quick down, wg0, and then just bring it up. So ignore the error there, because obviously the rules didn't exist for it to take those rules out of the Iptables chain. But now we bring it back up and this should now be working. Well, it would if I typed in the right command. Let's try that again. Okay, so you can see that last line there that says that shows us the Iptables commands we just typed in. Now on the client there's one quick change we need to make. WireGuard will only allow traffic through from IPs that are explicitly allowed in the configuration file. So right now the configuration file on the client only allows traffic from 192.168.9.1. So any traffic coming from any other IP will be dropped. So we changed that from 9.1 to 0.0.0.0/0. So essentially any IP. So that means any machine on the internet, anything out there, if it's sending traffic in through the tunnel, accept it. And obviously you need that to work for traffic from the internet. If you're connecting to a private network, you would put in your IP settings appropriately. Take the interface down on the client, bring it back up, and just like that, it's that quick. It's less than a second, and now all traffic should be going through the tunnel. Let's test that out with that command to see our public IP address. And now the public IP of the server and the client should be the same. And it is. So all the traffic from the client is now being tunneled through the server and then to the internet and then back through the server to the client. Now that everything is working on the server, the final step is to set it so that on reboot the interface comes up and the server is ready and listening for and waiting for clients. So a couple of things before that, we just set the ownership in the WireGuard directory to root and make sure no one else can access those files. Again, these are security keys, so you don't want them being accessed. It's not a big deal in a home lab, but it's just good practice. So after those 2 commands, we create a service and enable it. And then once that is done, we can just bring the interface down and then start it up through the service, and that's it. So it's running. So now every time we reboot, the server will be ready. And now the final part of this video is setting up WireGuard on Windows 10 so that we can connect to the server we just configured and tunnel all our traffic through. Now I'm aware at the time of this recording that there is no official WireGuard client for Windows 10. So I will be using a client from Tunsafe. You may want to look into that if you would rather not, but it works for me. So here's my public IP. My ISP is Bell Canada, and this is obviously without connecting through the VPN. So let's go ahead and download and install Tunsafe. I should say that this is a Windows 10 VM as well. It's brand new. There's nothing really installed on it. So you go to tunsafe.com, and I find that the download that I get is usually the release client. It works fine for me. I've never really had any issues. Your mileage may vary, I guess. So if you really want to be safe, like download the stable version, but RC2 works fine for me. And again, by the time you see this video, this might all have changed. If there's an official WireGuard client, use that. It's a really small install and small download, and it installs quick. So there's no changes, just click through. It installs a tap adapter. Let it do that. And once it's installed, we have to do 2 things now. We have to create a config file on the client, on this Windows client, and we've got to create, add it to the server. So the first thing you'll need is a private key and a public key. So Tunsafe comes with a nice utility that generates a public and private key for you. So just copy and paste that into Notepad because we'll be using these when we create the config file. And then I'll just save that on the desktop so that we have that file. All right, so the next step is to create the config file that we're going to install on the client. It's almost exactly the same as the one we did on Linux. The only difference will be in the IP address. So this machine's IP, I'm going to set it to 192.168.9.3. If you recall, our server was 9.1 and I set the Linux client as 9.2. So this Windows client is now 9.3. The private key is right there in the Notepad file that we just saved. So I'll get that and paste it in. And just like on Linux, these are the only two lines we need for the interface. And now we've got to tell the client which server to connect to. So we need the server's public key. For that, I'm just going to bring up the server's command prompt window again and type in WG and just dump out the public key. So there's our public key. And if you notice in the red window, there's one peer connected right now. So this is the second peer that we're connecting to the server. So the endpoint IP address is the public IP of the server, followed by the port that Wireguard is listening on. Again, the IP was, there it is, 207.148.8.203. And you may think that I'm showing you the public keys and private keys and the IP address, but by the time you see this video, all of these servers will have been taken down. So I wanted you to be able to see the process step by step. So don't worry about, I'm not really exposing anything of my internal network. So we set the endpoint and we set the allowed IPs. I'm just going to start off straight by telling it to allow anything coming from the server. So we'll be able to connect to the internet directly. You could set this to the server's IP or to some other network range that you have behind the server, but in our case we're just going to stick with everything. And then I'll save this as a text file on the desktop, and then I'm going to just go and change the extension of this txt file to .conf. So I have show extensions enabled, but you could do this from the command prompt or any other way that you want. So once it's saved as a .conf file, go to Tunsafe, import this file. It'll move that out of the way. It'll import it in, and now we should be able to connect. But before we do that, though, we won't be able to connect right now because we've got to first tell the server that we've added another client, another peer, and we have to tell the server what that peer's public key is. If we don't do that, it won't let anything connect. This is somewhat different from how OpenVPN and other VPN services work, where the server doesn't need to be explicitly set up for every peer. And maybe Wireguard, there's a way to do that, but I haven't found that out yet, so I have to do this manually every time. It's no big deal for when you have 2 or 3 machines connecting. Personally, I have 2 machines plus a couple of phones that connect, so I only have 4 peers. But here, so let's add the peer to the config file on the server. I'm just leaving a couple of comments so that I know what's what. So we paste the public key that we have from the Windows machine, and the allowed IP is 9.3 and only that IP. And then we save that the config file, and then you take the interface down and bring the interface up again. And now when we bring it back up, the server will be ready to accept traffic from the Windows workstation as well as the Linux workstation. All right. So now we see there are 2 peers that have been added, and 9.2 and 9.3. So now let's try connecting from our Windows machine. So if we hit connect, we should be able to just get through directly. I'll just remove, we don't need the server anymore, so I'll get that out of the way. Before we connect though, let's just reiterate that this machine's public IP is the same as my internal network's public IP, the one that's given by my ISP. That's 74.12.93.106. So if we are able to do this correctly, we should see that change, right? So let's hit connect. Yeah, just make sure we got the right. And there's a configuration error. So this is something to do with how the Tunsafe adapter works on Windows. I'm not sure what the precise details are, but I do know that to fix it, you've got to go to the interface address and add a /24 netmask to it. Then it works. I'm sure someone who knows more about networking can figure that out and tell us why that's the case. But it's connected. It takes less than a second. Let's do that again. You hit connect, and before you can blink, it is connected. And now if we open up Firefox and look at our public IP, we should see it going through the server that I've got running. And there you go. So my server's running on Vultr, so it's in the US, and now all my traffic is being forwarded through that. So WireGuard does take a bit of getting used to, but once you got used to it, setting it up and getting it running is easy, and it is so fast. So I hope this guide helped someone. If you've got any questions, leave it in the comments below and I'll try my best to answer. Thanks for watching.